Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from downtown Raleigh today, day 2 of All Things Open, the open source conference. About 2,500 people here today. Got a co-host today, Josh Atwell. Welcome to the show.
Thank you.
To help me out. Yesterday was your birthday, so happy birthday!
Thank you again.
That. And so today we're gonna get a little bit off topic from a cloud computing perspective, but something that we covered a year and a half ago that you guys all seem to like. We're gonna talk a little bit about 3D printing again. And excited to have Harris Kenny, VP of Marketing from Lulzbot. You guys are open source hardware 3D makers. First off, give us a little bit about your background, and then tell us about Lulzbot.
Sure. Thanks for having me. So my background is in actually management and ERP consulting, so not hardware, but philosophically, I was excited about the open source hardware vision of the company. So that was how I ended up at Aleph Objects. And the company itself, so basically it runs on free software and open source hardware, and our products are totally open source hardware. We've got from the software that you use down to the hardware, the bill of materials, you can flash the firmware, the whole stack respects user freedom. Okay, and you guys are essentially the biggest maker of desktop 3D printing devices and the whole ecosystem around that. We're growing. I'm not sure the biggest by market share, but we're definitely growing a lot. Over the last 3 years, our market share has gone up a lot. Yep. We've got 140 employees now. Okay. We run production 7 days a week, and we've got we're definitely staying busy. Yeah. So you guys are a U.S. manufacturing sort of powerhouse or growing thing, which is very cool. Give us a few of the basic things. So, like, if anybody says, Josh and I live in the open source software world, right? We get that software's eating the world. What does open source hardware mean? Like, for somebody who doesn't understand what that means. Well, the idea behind open source hardware, what is really compelling about it is that you really own the things that you have purchased. And so when it comes to a 3D printer where it's got a motherboard, you can flash the firmware, you can control the machine, which is exciting. But a lot of the source materials are different for hardware. It's going to be a bill of materials that's going to be an itemized or BOM, itemized BOM with suppliers, with prices, part numbers, things like that. There's, of course, making it, and the assembly instructions, we release those. If you go to ohai.lulzbot.com, you can see the pictorial assembly instructions for how we make the printers. It's the same exact instructions our folks use. So there's like how you make it and what it's made of, and then how you use it. Gotcha. So, and for those of us that deal with like x86 computers, that seems sort of that. But your world, that's never been the case. Manufacturing was very proprietary, complex systems, I'm guessing. Definitely. And I think, if you go back decades when you bought a dishwasher and you got a manual, it would explain a lot of things. There was a little bit of I think some philosophical alignment with the way some hardware used to be made, but it's over the years. OEM, original equipment manufacturers, have shared less and less, and more of it has become abstracted through software, and so you lose insight into how the things that you buy work. Gotcha. Yeah.
So with this product, then, is it that I buy it and it shows up as a kit and I put it together with my kids and then following the instructions and then we go, or is it I can also go out and just I could build some of the pieces out of mahogany if I wanted to, based on the spec that you have for the frame and all, and then buy certain components. It sounds like I have that kind of freedom. Is that part of what y'all were talking about?
That's a really good question and a really important distinction, actually. So we don't sell kits. We sell fully assembled printers. You can buy them.
Okay, good, because that's what I need to buy.
Yeah, and most people are like that. I'm like that, by the way. Right. I have not built a printer from scratch myself, but you buy them on Amazon. Take it out of the box, plug it in, download the software, and start printing. But there are people that have used that source to make their own. We had a customer who machined one, and it was like an all-metal printer. It was beautiful. He had a lot of CNC background, and that was his thing. Right. So he did make his own, and folks do make their own. But it's more of, like Linux, you benefit from the people before you without having to be a kernel compiler. So if you're or a kernel developer. So if you're running Fedora at home, you benefit from that, but you're just using Fedora.
Right. Kind of reminds me of the old Linksys WRT 54G routers. I think everybody listening to this podcast probably has one in a closet somewhere and has flashed that firmware and kind of turned it into their own. I know I've probably broken it more times than I've plugged it in at this point. But in this case, you also have the opportunity to like rip the guts out and swap those components, right?
Yeah, exactly. One of the neat hacks that people do is they'll take these maker electronics like a BeagleBone Black or a Raspberry Pi, and they'll hook it up and they'll set up a web server with a software called Octoprint, and then basically they've got Wi-Fi based printing. So there are some neat electronics hacking that folks do. We had a customer at NASA that hacked the firmware to remove the like upper temperature limits, and so they were printing above 300 degrees Celsius and doing some really experimental, crazy stuff. And we're like, wow, like how hot did you go again? And this is like they're professionals, don't print at 500 degrees at home. But so yeah, people take advantage of that for sure.
Yeah. So we were talking to you beforehand. Most of us have been to somewhere where somebody's printing 3D stuff. Typically, there's a big spool of the colored plastic, and that's you tend to think like, oh, okay, that's the material we use. And you were telling us like that what you can build with these days has exploded. Like, give us some examples of some of the stuff, especially some of the chemical stuff and all that you were talking about earlier.
Mm-hmm. Yeah, there are dozens of actually. On our machine, we support over 30 different materials, so there's lots of choices in terms of what you print with. And a few examples that have come to market over the last couple of years actually came from other industries that were then brought to desktop 3D printing. So there's a urethane, a rubber-like material called NinjaFlex that was developed by a company called Fenner Drives, and then they basically brought it to the 3D printing market. And Eastman Chemical Company, same story. They work with copolyesters, and so if you have BPA-free water bottles, you've used copolyester. It's like the thick, translucent, transparent plastic, right? And so you've got all this like expertise and knowledge and material science from other industries being leveraged into 3D printing. And so it's hard to predict kind of what's next because you don't know who that next big player that's sort of like dormant, sitting latent with all this information is going to decide that they want to play in the 3D printing industry. And because it's open standards, the open source couple $1,000 desktop 3D printers are on the bleeding edge versus machines that cost like orders of magnitude more money but have a really proprietary system and chips and reading and testing, and you don't really own those printers. So for $1,250, for $1,250, you can literally be on the absolute like bleeding edge of the industry, which is I think counterintuitive for people.
Right.
That's very cool. So I mean, that also begs the question, like organic stuff like chocolate or food. Like, are we starting to see that now as well? And do you guys support that yet?
You can't print. Well, actually, yeah. Okay, so indirectly, we've got a customer in Australia who. So speaking of like organic printing, the project is called Future Here, and they're using our machines, Lulzbot printers, to basically, first they scan an ear. So these are ear prosthetics for kids, or they're serving children. It could be for anybody, but scan the ear, refine the model, print it, and then use that printed plastic to make a silicone mold.
Okay,
and then they can then get basically a prosthetic grade silicone. Yeah. So. Like indirectly, you're not literally printing flesh, but in a sense, you have even more control in this process, and because of the price point, it's accessible. And there's on the high end, there are companies doing some really kind of crazy things, printing with like tissue scaffolding and food. But even at the desktop market, you're seeing innovation, and the lower price begets like resourcefulness.
Yeah. So give us the basics of the economics. So you said like your kind of core platform is about $1,200, $1,250. Yesterday, Mark Hinkle, who did one of the keynotes, was talking about one of your, I think, customers, or at least one of your people in the community, had built a prototype for a prosthetic hand, and I think Mark said like what would have been $60,000 or $600,000 in the hospital was like $5,000. And so, give us a sense like what did an old-timey manufacturing, the thing that would make it, used to cost? So, like, what does that economics look like? And then the output economics look like? Give us some sense of, how many orders of magnitude are we talking about, or where are the big kind of break points?
Yeah, that's a great That's a great question. And that idea of, that's really, I think, where the disruption is coming of like, how do you compare 3D printing to the other ways of making things?
Right.
And like, why is this interesting?
Yep.
Because like, whatever, it's a robot that melts.
There's the powerfulness of like anybody can do it, right?
Yeah.
You don't have to own your own, plant anymore. But what do the dollars and cents look like?
Yeah, totally. So that customer, user of ours, Easton LaChapelle, he's actually from Colorado,
Okay.
and that Mark talked about in his talk. And yeah, so he's doing prosthetic arms and really, really neat work. And there's a couple other projects doing cool prosthetic applications. Basically, injection molding would historically be, and for a lot of companies, that's when they get big enough, and they want to make tens of thousands of a thing,
right.
a widget, that's what they have made. And injection molds can take weeks to months. They can cost tens of thousands to even more of US dollars. And it's just the time. Time to market is slow. And so where 3D printing is really disruptive is in underserved markets because they're small. Mm-hmm. In other words, they're not big enough for a company to justify the expense of like getting tooling done and because it's just as expensive to make 10,000 as it is to make 10.
Okay.
Which benefits the people that need 10 of something
right.
more than anything else. So that's one side of it. And then the other side of it is that the printers themselves are getting more reliable, so they actually are being used. We've printed over 1 million parts.
So you're 3D printing the printers that you're then selling. So that
exactly
inception going on.
Yeah, exactly. Printers printing printers, and when they run this cluster of 150 machines runs 24/7, and we've got using old machines. We also test new things. It's like an R&D process where we can try a new material or try a new print surface. So there's lots of benefits that come from that. So yeah, it even benefits like medium-sized businesses. It's not even just for small things. Like we have 140 employees and we run production 7 days a week. Like we're making a lot of printers, and they're being supplied by us in part.
And it sounds like there's a whole slew of other businesses that are being spawned off of being able to leverage this platform. How does the open nature of the platform? How is that helping them? Are they now contributing to firmware revisions and they're contributing to new code and new models? How is that that relationship kind of happen? Because it is open, right?
Yeah, the biggest contribution that entrepreneurs. There's tons of these companies that you could think of. One is OpenBCI. They're in Brooklyn. They do a brain-computer interface, almost entirely printed device. It's a fraction of the cost of these types of devices in the past, and it measures EEG, EKG, and EMG. So it's like a brain wavelengths, heart rate, and muscles. It's like a really powerful device. And what they do, their contribution back really, I think, is inspiring people. They haven't made commits to our firmware. They haven't changed our software, but they show people like, hey, this is how like radical of a product you can make with 3D printing. And I think that like those lighthouse examples where people look to them and be like, oh my gosh, that's cool.
So this is materials plus integrated circuitry and the electronics and everything kind of combined.
Exactly.
Yeah,
that's neuroscience.
Yeah, that's much more interesting than the cookie cutters and Lego figures that I want to make.
Yeah. Well, there's nothing wrong with those simple applications. I think of cookie cutters are fun because they're accessible for folks. And we have other customers who have unique use cases. There's a company called Protosthetics in North Dakota, and they're doing, in particular, leg prosthetics or prostheses.
People's legs actually freezing off living in North Dakota. So a whole industry built around that.
Yeah, and they're hacking the hardware. Yeah. They're making the printers bigger. So they're physically hacking the machine.
Printers.
Yeah. Exactly.
So they're making them like 3x, right?
Exactly. Okay. So they're like physically hacking, but when you're physically hacking, there's software changes that need to happen with that, and so other people see that and they can make feedback. So that's helpful, and then just the customers that are heavy users that give us feedback. Our tech support, because our company is open and our ERP system, all of our modeling software, everything is open. Even just sending an email to our tech support people and saying, hey, this part isn't working. That is circulating across the company, and if we recognize a problem, we solve it. We change the file in the print farm in the cluster. We get new parts down in production, and then the next customer that buys a printer that next day, just because of that email, has a better product because of it. So even those contributions are really meaningful.
Right. And when your ability to adjust as those things.
Yeah.
I mean, it also sounds like you have an opportunity now to do customization, to where if people wanted a custom spec on certain parts, well, I mean, I guess they could print their own. Actually, you don't even need to talk to you.
Yeah, exactly. Yeah, they don't even need to talk to us, and that would be what we recommend. And that's what people do. I mean, we see things in the field. It's like, wait, what? And those ideas have gone from our forum into products. We've got, our print surface, and there's so many things that came from the community. Our print surface, our leveling sequence, those are two hacks, for example, that customers that we got from the community and then basically commercialized. That's like what our engineers spend a lot of time doing, is like testing out these ideas we see in the community to make sure they work at scale.
So I noticed yesterday, or maybe it was the day before, you were over at NC State University, North Carolina State University, here at their engineering organization. You talked about people making prosthetics, so it's in the healthcare industry. It's like technology is now capable. Are you seeing more and more universities have things that are specialized around this and what it can mean for different than verticals?
Universities and libraries are leading this conversation in a lot of communities. Yeah, and NC State is a great example. I spent the afternoon with folks at a makerspace there, and then I got a chance to tour the rest of the library. And so that makerspace they work with a bunch of different departments. They work with arts, engineering, but art is in particular interesting because folks come from the art school and they have totally different ideas.
Yeah, design ideas, sure.
Yeah, exactly. So yeah, and universities are the place. It's where you go to learn. And what's really interesting is that libraries in particular are kind of, it's the historical place. It was like if you needed technology, if it was a book or if it was a journal, you'd go to the library. And now technology is obviously computers and 3D printers, and they have 270-degree immersive video and audio. I mean, the technology they had in this library is incredible. So they're not only doing it themselves, but they're serving the rest of the campus. They're serving the community. It's really exciting. It was a very inspiring afternoon, honestly.
Well, I know NC State has a long history with 3D printing. I attended NC State. I did aerospace engineering there, and when I attended like an engineering seminar, or like it was a whole summer of engineering, and we got to be introduced to their initial 3D printers that they had. So I got to learn how to draft and build. I went to visit another college campus. I won't name who they were, but we walked into their room where they had one of their 3D printers. I think State had like two of them. And they're like, we're one of two universities in the country that have these. It's us and MIT. And I'm like, well, that's not exactly right. NC State's got two of them. And they're like, that's impossible. That's not true. And I'm like, okay. So I pulled out my floppy disk. I sat down at the machine. I loaded up the design that I had done here at State. And I went to start printing it. He goes, whoa, what are you doing? I was like, how could I possibly know anything about this? So, yeah, and it's been interesting because, you mentioned about the libraries. They're now having this. Having an open framework makes it a little bit easier, especially for smaller libraries, smaller groups to do that. I've seen schools start showing it. I think my son's elementary school has a 3D printer that they use from time to time. And then I know in the Raleigh area, there's a couple of places they're like build shops, right, where they have multiple different types of 3D printers. I think the big thing that comes out of this is like the community. The community's gotten kind of huge around 3D printers. How's that affected you guys?
The community is really big and it's really diverse. So our company spun out of a community project called the RepRap project, and we're still involved there. But the RepRap project grew. Basically, the desktop industry, as you know it today, is possible because of open source.
Yeah,
because some folks in England about 10 years ago decided we want to make a printer that prints itself, and we're going to use a free software license to share it. And because of that decision, basically, the 3D printing community exists today, and it's really incredible, folks. And because it ties so many different things, you could be meeting with other 3D printing people, and printer doesn't come up once in a 30-minute conversation.
Yeah. Now, is it the 3D printing community, or is it the maker community, or for anybody who's kind of looking at this and they're going to Google stuff, like what community are they trying to find?
It generally is. I think makers is a good term because it does kind of cut across technologies, where it's like someone's like, oh yeah, I use a printer and I sew and I use a laser cutter for projects. There are those types of folks, but a lot of it is, hey, I've just got some interest in something else. Like I love model trains. And I make my sets, then I run the trains around my basement, and then it's like, oh, I could print trees or houses instead of making them by hand. Right. So I think there's like two sides of it. There's one of like people that just make, and others that folks that have some like bigger thing they're trying to do.
Yeah.
So.
Okay. So I'll ask you one last question, just from a time perspective, and it's not trying to be political or about any of this, but people want to know, we're in the political season, like, are there going to be more jobs? Are we going to see manufacturing come back? I mean, do you guys get involved with those? Are there people from your company, or is that, I mean, do the people start going like, oh, maybe this is the thing, just like people are looking at like solar energy for, that part of the world? Or, I mean, where does this sort of stand in terms of, big topic issues like jobs and manufacturing back in the States?
I think that there's a few connections between this conversation and manufacturing overall in the U.S. and other
places,
other countries and other places. So one, 3D printing makes it less expensive to prototype a physical product and bring it to market.
Yeah.
So that's going to help, and it is helping. We have customers we talk to them every day, and they blow our minds. I mean, like the OpenBCI, for example. I mean, it's so it makes it easier to bring things to market. That helps. I think that the open source hardware side of it also helps, because it basically, a lot of companies historically just were all reinventing the wheel over and over again. And in open hardware, you basically take ideas from other technologies, from other platforms, and you use it and you share it back. And so I think it makes manufacturers that are sharing more efficient, more productive, and therefore it changes the economies of what it means to make. So I think those are two really big improvements. And then I think just more broadly, using open source within the enterprise,
right,
and using like the broader open source community to make businesses run better. And I think that that's something that those are three kind of like economic factors that'll make it easier for people to make things.
Well, and you talked about like you guys are your own supply chain. So I mean, you're changing that economics and that as well. So that does change a lot of things. Well, listen, I'm gonna wrap it up with that. I need to apologize. So I'm proud of myself. I didn't call you Kenny Harris. You're Harris Kenny. So I was worried about that because I'm terrible with names. But I just screwed up at the beginning, and I introduced you as being with Lulzbot. That's your product. You're with Aleph Objects. That's the name of the company. So I want to get that straight. Thank you for coming on. Where can folks go find out about the stuff you guys are working on, or events where people can come find you and stuff like that?
The best place is our website, lulzbot.com. Okay. So that's LULZBOT. If you go to lulzbot.com/community and you're curious on like the developer side of things and what we're doing, the communities that we're involved with, there's a great set of resources there. So I think those would be probably the best two places to start. And then, of course, we're on social media and Twitter, and very cool. That's a good place to find us too.
Very good. Well, thank you for being on. Josh, thanks for being on. I think you may have added to your list of things you want to 3D print now that you know all the materials that are possible. And
yeah, absolutely. My next thing is a replica of the SpaceX rocket. That's how they build them, right?
That's right. Fired out of your backyard. Well, thank you very much. And folks, we will talk to you soon. Thank you.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.